This is problem 4 from the chapter 1 closure packet. It says solve each equation. Make sure you check your solution. So we want to make sure we check our answers. We can always be sure if our answer is correct by plugging the number into the original question. So we want to start by solving these equations. We want to end up having x's on one side, and then the equal sign, and then a number on the other side. So all we're trying to do is move all the x's to one side and all of the numbers to the other side. So for problem A, and it might help, I'm going to draw this dashed line here. That's up to you if you'd like to draw that. Sometimes it helps people. So I want to first look at if there's anything I can combine on either side with each other, combining like terms. So on the right side, there's a 4x and there's a minus x. So I'm going to combine those together and then it'll become 3x. And then I'm just going to copy down what I didn't change. So I didn't change that 8 on the right side, copy the equal sign, and keep that, 3x minus 1 on the left. Alright, so now I have combined all my like terms, so now I need to move things to the left and the right side. Now, and to do that, we do the opposite operation. So I'm going to move this 3x from this side, so I want it to be gone. So I'm going to subtract 3x. I want to do the opposite of adding 3x, because then this result will give me nothing. It'll give me 0. So those are now gone. But I have to subtract 3x from the other side as well, which happens to also be gone. And that doesn't always happen. So I'm left with this -1 equal sign and an 8. So I'm just copying down what I didn't do. Since both of these things happen to disappear, I'm just not going to write them in my answer. So I have -1 equals 8. Now think to yourself, is that a true statement? Is -1 the same as 8? Well, no. It's not the same. They're not equal. So this means that x is going to be, there's no number that x can equal to make the left side equal the right side. So we call that no solution. There's no number that x can be to make this left side equal the right side. Okay, so there's not really a way you prove your work to check that one. You could plug in a number and see it does not make the left side equal the right side. So you don't necessarily need to check it when it's a no solution. Let's look at problem B. I'm going to draw my dotted line again. I want to first look, can I combine any terms on the left or the right side? There's no extra x's over here. There's just this one term. There's no other x's or numbers over here. There's just one of each. So I'm going to go ahead and start to move things. So I'm going to move this 7x. So to move it, I subtract 7x. And I have to do that to both sides. And I'm doing that to make this right here go away, for that to become 0. So I'm going to cross that out. Alright, now this 5x minus 7x is going to be -2x. Then I'm just going to copy everything else down. -10, equal sign, and that -4. Make sure you keep that symbol with it, whatever it was. Alright, so now I have my x's on the left. I want to have my numbers, just like we said up here, I want my numbers to be on the right side. Now, it doesn't necessarily need to be on the right side, but one or the other sides. So I'm going to add 10 to make this go away. Alright, so I have left over here -2x equals -4 plus 10 gives me a +6. So now I need to get an x by itself, so I'm going to divide by -2, because this number right here is really being multiplied by x. So I want to do the opposite operation of multiplication, which is division. So I'm going to divide by -2. Make sure it's by a -2, not just the value 2. So -2 divided by -2 just leaves me with an x equals -3. And that's my solution. Now I need to check this by plugging it in. So if I plug it in the left side, that's going to give me -25. And if I plug it in the right side, which was +7x, x, we're going to replace x with -3. And then I subtracted 4, so this would give me -21 minus 4 is also -25. So that's my check. I'm plugging the number back in. Alright, so problem C, we're going to combine the 28 and the +4, so that'll be 32. And I'm just going to copy everything else down. Okay? So now I want to get all my x's on one side, so I'm going to add this 3x. You could have added the 6x. We just want to get rid of an x on one of the sides. So now I have negative 6x plus 3x gives me negative 3x. And I'm going to copy down everything else that was still there. Okay, so now this is going to be my x side. So this side has to be where all the numbers are. This is not supposed to be on the left side anymore. So I'm going to subtract 32 to make that go away, make it become 0. That's why I can scratch it out, because there's nothing left when I subtract them. So 30 minus 32 gives me negative 2. So I want x by itself, so I need to divide by negative 3. Divide by negative 3, make sure it's negative. If it's a sign out there, you need the sign. So all I have left is x equals this negative divided by this negative makes it a positive 2/3. Okay? So now I want to check this as well, and what I can do is I can just type these on my calculator actually. So 28 minus 6 and then type in 2/3. And fractions are just division problems, really. And then I had to add 4, and that gets me to 28 when I do it on the left side. When I plug it back into the right side, I have 30 minus 3 times 2/3. That also gives me 28, so I can check that way that my answer is correct. For part D, okay, I want to first combine my like terms. 9x minus 5x, that gives me 4x left over. Copy down everything else. Copied everything else, okay? So if you notice at this point, it's the same on both sides. It's exactly the same. 4x minus 1, 4x minus 1. So if you notice that, you can jump down and say, since this side is equal to this side, that's a true statement, right? I can say that x is going to be all real numbers. Now, if you don't realize that yet, if you don't realize that they're the same, you just keep going through the motions, well, let's get all of our x's on one side. So I'm subtracting this 4x is really what I was thinking about, but they both happen to go away. They both equal 0. All right? So now I have negative 1 equals negative 1. Is that a true statement? If it is, then that's how I can go to here. Let's say I can plug in any number for x, and the left side will equal the right side all the time. Okay? So that for checking on that one, you could really plug in just a couple of different numbers into the original question and see if the left side is equal to the right side, and it should work for every single number that you plug in.